Okay, so here we go again. I want to define for you what's called the primitive root. Now, the primitive root mod m of m of a mod m does have something to do with roots, but this brings us into abstract algebra, and I'm not going to go there. I'm actually going to use the definitions Underwood-Dudley uses and keep from the algebra. Basically, the definition of the primitive root is any a that has ordered the totient function of m when you mod by m. That's the order. That you can't find an earlier power that takes a to 1 other than the totient function. If you recall, by Euler's theorem, if a and m are relatively prime, then the totient function is a power where a to that power is equal to congruent to 1 mod m, but there could be smaller powers. In the case there's not a smaller power that takes it back to 1, this is called a primitive root. So an example is 3 is a primitive root mod 7, not mod m here, mod 7. Because if I take 3 and the totient function of 7 is 6 because 7 is prime, and if I take the powers of 3, the first time I get 1 mod 7 is when I take 3 to the totient power. 3 to the 6 is equal to 1 mod 7. Notice here that if I list the numbers from 1 to 6, the first, I have 1, 2, 3, 4, 5, and 6. So it turns out that the powers of this 3, because the powers of 3 that I get are really a rearrangement of 1 through 6. So what is this rearrangement all about? Well, if g is a primitive root of m, then these numbers that you get when you take g and raise them to a power are just a rearrangement of the phi of m positive integers that are smaller than m and relatively prime to m. So for example, 2 is a primitive root of 9 first because phi of 9 is equal to 6 and 2 to the 6 is congruent to 1 mod n, or that the order is equal to phi of 9. If I take the numbers from 1 to 9 and I just take the ones that are relatively prime to 9, notice that all of these numbers appear in this list. 1 is there, 2 is there, 4 is there, 5 is there, 7 is there, and 8 is there. So it's just a rearrangement of the relatively prime numbers to 9. So homework for the test, to practice for the test, is to show that 3 is a primitive root of 7. And find a primitive root of 10. Just play around and find a primitive root of 10. Any one of them. Just see if you can find it by playing around. Now, I'm assigning 1 through 5, and you can use any of the theorems in this section to solve these problems. So number 3 tells you that one of the primitive roots of 19 is 2. Find all the others. Well, the first question I have is how many others are there? Theorem 6 in the book says that every prime p, in this case, our case, p is 19 and it's prime, has the totient function p minus 1 primitive roots. The totient function of 19 minus 1, which is the totient function of 18, is 6. That tells me that there's going to be 6 primitive roots. We also know that phi of 19 is 18, and all the orders must divide this number 18. So I'm going to list the divisors of 18, and they are 1, 2, 3, 6, 9, and 18. So I'm just going to check that 2 indeed is a primitive root, and it is, because 2 to the 18 is the first one that gets me back to 1. But what are all the other ones? I've got 5 more. I've just got one of them. Well, there's another theorem that says if A has order T mod M, then A to the K also has order T mod M if and only if K and T are relatively prime. So if I start with 2, the relatively prime Ks to the order 18 are 5, 7, 11, 13, and 17. So those are my potential powers. So that means that by this theorem, 2 to the 5th, 2 to the 7th, 2 to the 11th, 2 to the 13th, and 2 to the 17th are all order 18. And this does it. I have them all because I know that my total is 6. I already know 2 is one of them. So these are the other 5. And of course, these are not reduced. I need to reduce them mod 18. I was too lazy to do that. So this is basically how you do the problems. 1, 2, and 3 are fairly easy. The last ones, 4 and 5, are a little bit more like this one where you have to think and use some theorems. I think I've already used all the theorems that are in your book to find some of these primitive roots. If you have any questions, email me and ask. You can send your work to me and I'll look it over.